Welcome back, everyone. Here we are in module 3.2, where we are going to be continuing down our path of learning more about Bearcat Incorporated and creating an ER model that captures all of their business requirements. So one of the things that we're going to need to look at as we continue down this path is a different or an alternate way of reading and writing our entity relationship diagrams. So what we've been using so far, we've called the look across method, where we look across the relationship to determine the participation and cardinality of an entity. So this is the example we had earlier in class, where a plant undertakes 0 to many projects, and a project is undertaken by a minimum of 1 and a maximum of 1 plants, right? We look across the relationship. That's why we call it the look across method of reading these diagrams. We can also use the look near method, okay? And this is just an alternate. We can do the same things with either one. And instead of using the dash and the M and the N near the relationship, we're going to put our cardinality and participation constraints in parentheses on the line between the entity and the relationship. Okay, so this is saying a plant undertakes a minimum of 0 and a maximum of many projects, and a project is undertaken by a minimum of 1 and a maximum of 1 plants. Okay, so now instead of reading across the relationship, we're looking near the entity to get the participation and cardinality constraints. Okay, so both of these presentations, both of these diagrams are saying the exact same thing. Okay, so this is the cardinality or the participation of plant and the cardinality of plant, whereas this is the participation and the cardinality of plant when we look across. And this is the participation of project and the cardinality of project, whereas in the other diagram, this is the participation of project and the cardinality of project. So they mean the same thing. Use one or the other, but not both at the same time. So where we stopped earlier, right, this is what we had done so far in class. We also could have written kind of like this using the look near notation instead of the look across notation. Okay, so both of these represent the same thing. And one thing I will point out that's kind of nice about this look near notation is where we previously said we can't really capture that a plant has to have a minimum of 100 employees. We just captured that it has mandatory participation. We can capture that in this look near notation. So just kind of a different way of approaching things. You know, we can do whichever fits our business need the most. So we got to this point, of course, by decomposing our story, right? We took this big, 1-page long story. We broke it up into these 5 smaller chunks where we had the story about plants and projects, right? And then the story about employees and plants and projects. And then we just combined those together. And then the third story about employees supervising other employees. And then we glued it on what we had already done, right? And then the story about employees having dependents and BCU accounts and all that. Attach that to what we've already done. And then the same with the employees and their dependents and hobbies. So we took all these small stories and we put it together to create this large and more complex ERD without pulling our hair out through the whole process, or hopefully not pulling our hair out through the whole process, right? And then we realized that we had an error in our model in that we could have potentially BCU accounts that are owned by neither employees nor their dependents. And we resolved that by including this either or both arc. So this is version 0. This is just kind of the first step toward modeling everything the company needs. So now we want to go back through the story and kind of keep iterating and keep adding more and more details, right? And we're going to write down some of our constraints and some of the things that we've identified in the story and do this until we've captured everything. So as you read through the story, you're going to find a lot of things that are clearly attributes of these entities. And we're not going to go through that in class because I think this is something that you guys would probably feel comfortable doing. We did this in homework 1. We did it when we created our horse model. attributes like name, color, spots, gender, and weight. And if we did take the time to go through the whole story, we would wind up with something like this. And building on what we already know about our ER grammar, note that we're able to capture a lot of detail about these attributes, right? And there's a lot of kind of weird things in this story. This comes straight from your textbook, and one of the things it says is that salary is optional, to have a value for salary. That, I don't know, I think I would want to know what I'm paying my employees, but in the story, salary is optional, so we represent that with the circle that's not filled in. But then other attributes like gender and the date they're hired are mandatory, so we represent those with these filled in dots. Employee ID is a unique identifier, so we have a solid underline under that attribute. Name is a composite attribute made up of these atomic attributes of first name, middle initial, last name, and name tag, which I think is the salutation, like Mr., Miss, Doctor, whatever. Dependent is the attribute dependent and the entity dependent, which, as we previously discussed, is a weak entity, is a partial key. So we identify, or we notate that with this dotted underline. And what that means is that this value is not in and of itself unique. It's only unique when it's combined with the primary key of the base or strong entity that identifies it. So it's only this combination of emp ID and the dependent's name and how they're related to the employee that can uniquely identify a dependent. And this is a bit of a convoluted way to come up with a unique identifier for dependent. I don't know if this is what we would actually want to do in a real implementation, but this is how it is described in this particular story. So that's what we're documenting here. Number of employees is a derived attribute, which would be derived by counting the number of employees in this works-in relationship with the plant. And then hours is an attribute of not the employee entity or the project entity, but of this relationship between employees and projects, right? So this is similar to how when we had, in our previous example, students and dorm rooms, and the amount of rent they pay was not an attribute of the student or the room, but it depends on the combination, right? And if you think about it, the number of hours, if that was an attribute of employee, we would be seeing the number of hours the employee worked across all projects that they were assigned to. And if hours was an attribute of project, then that would be representing the number of hours spent on that project across all employees. But with this being an attribute of the relationship, what this is capturing is the number of hours each employee has spent on each project. And then based on that, we could calculate the total number of hours an employee has worked or the total number of hours that have been worked on a project, right? So this attribute takes on a different meaning depending on where we put it in our model. Then we have an attribute here, building, which is a circled dot, which means this is a multi-value attribute. So we're going to have multiple, or potentially have multiple buildings for each plant. So that's what that represents. And we're going to revisit some of these things as we dig deeper and deeper into this model in our next class. So the other thing that we're going to be talking about as we progress through making this model more and more precise are our deletion rules. And to kind of review, we had 4 deletion rules. The restrict rule, which says as long as an entity in the parent entity, as long as an instance in the parent entity has children, then we're going to restrict that instance from being deleted. Okay, if we try to delete a parent instance that has children, the database just simply will not let that occur. We had the cascade rule that says if we delete a parent, then that deletion is going to cascade down and delete all the child entity or all the child instances as well. The set null rule says if we delete the parent, the children can continue to exist. They just don't have a parent anymore in this parent-child relationship. And then the set default rule, which said if we delete the parent, then the very next thing the database is going to do is replace that parent with some predetermined default instance. Okay? So we're going to be operationalizing these kind of through the rest of tonight's class. And as we previously discussed, our restrict rule applies to the parent in the parent-child relationship, whereas cascade, set null, and set default all go with the child in the parent-child relationship when we're drawing these on our model. So this was the third file that was part of what you downloaded for tonight's exercises. And this is just kind of a cheat sheet where I've gone through the business case and distilled the 12 deletion rules that I was able to pick out of this story. So we're going to go through these and get these all documented on our diagram. So the first deletion rule that I found says a plant with employees cannot be closed down. So what we're talking about now is this relationship where we have employees that work in plants. And if a plant that has employees cannot be closed down, which of the 4 deletion rules does it sound like that is referring to? Restrict, right? We're going to restrict the deletion of a plant as long as it has employees. And in this relationship between plants and employees, which one is the parent, the plant or the employee?
Plant.
Plant, right? The parent is the entity that has a cardinality of many, right? A plant has many employees, has many children, but an employee has only one parent. An employee has only one plant, okay? So plant is the parent in this relationship, and the restrict rule goes with the parent. So that means we're going to put a little R right here on our diagram next to plant. Excellent. So that's our first deletion constraint now documented on our diagram. Deletion constraint number 2, if an employee is deleted, all BCU accounts of that particular employee must be deleted. So which of our 4 deletion rules does this sound like?
Cascade.
Cascade. When we delete an employee, we're going to cascade that deletion down to the BCU account. And in this case, employee is our parent because employee has the cardinality of many. Or if we just think about it, an employee can have many BCU accounts because they have their individual account and all their joint accounts. But a BCU account is held by a maximum of 1 employee. So we're going to notate this cascade rule by putting a C down here with the child in the parent-child relationship. Okay? So that's got our second deletion constraint documented. Yes, was there a question? Oh.
Yes.
Yeah,
There's
okay.
a question.
Good.
Yeah. Are we applying the cascade rule to employee and BCU accounts? I can't really see why we're doing that. Are we not supposed to be restricting as well?
So in this case, and this is just coming from, I think the second page of the PDF with the story, it has a lot of additional constraints and describing attributes and things like that. But one of the things it says is if an employee is deleted, all BCU accounts of that particular employee must be deleted. So we're really just capturing the business rules that are described in the case. And again, for kind of just ease of discussion, I've distilled those in a PDF that was on Blackboard. So where that was, rule number 2 at that point. Does that make sense? Okay.
Yeah.
Just capturing what's in the story. All right, so on to rule number 3, which says if a plant is closed down, then the projects undertaken by that plant cannot just be canceled. The project assignments from a closed plant must temporarily be removed in order to allow the project to be transferred to another plant. So we're talking about this plants undertake projects relationship. And we're saying if a plant is closed down, we don't just delete the projects, we just temporarily remove any assignment of a project to a plant so we can figure out what plant we want to assign that project to in the future. So which deletion rule does this sound like?
That no.
Set null. Yeah, we want a project to not have any plants temporarily so we can figure out where we want to put it, right? So we're going to put an N here to represent set null because project is the child in this parent-child relationship. Okay, moving on to number 4. The Human Resources Department uses a designated default employee number to replace a supervisor who leaves the company. So a designated default employee number, that sounds like probably our set default rule. And that's talking about this supervisor relationship. So the really tricky thing about this one is since we have this recursive relationship or this unary relationship, do we need to put that set default on this side or on this side? Right? And it depends on how we're reading it. An employee is supervisor for between 0 and 20 employees, but an employee is supervised by between 0 and 1 employees. Okay, so we're talking about setting a default employee as the supervisor for the child, and in this case, in this direction, it's the employee is the parent, and the employee is the child when we come around here. So we're putting the D for set default on this leg of this unary relationship. Okay? If you read it in this direction, this is the child being supervised by one employee, right? So this is the parent side of this relationship. Number 5, an employee currently managing a plant cannot be deleted from the database. So again, we're talking about the relationship between employees and plants, but in this case, we're saying we're going to restrict the deletion of an employee as long as they are managing a plant. And the restrict rule goes with the parent and our parent-child relationship, but in this case, we have a one-to-one relationship between employees and plants. And we've previously said that the parent in the parent-child relationship is the entity that has a cardinality of many. Well, in this case, we don't have an entity that has a cardinality of many. They both just have a cardinality of 1. So we really have to kind of just put on our thinking cap a little bit more for this one and say, you know what, we're restricting the deletion of the employee, not of the plant. So we really kind of are going to consider, at least at this point in time, the employee to be the parent, the way we're writing this. So we're going to put the restrict up here with the employee. We're restricting the deletion of an employee as long as they are the manager of a plant. Okay? But then kind of the other side of this relationship, number 6, if a plant is closed down, the employee no longer manages the plant, but just becomes a regular employee of another plant. Okay? So what we're doing in this case is saying if we delete a plant, whoever is managing that plant now is no longer the manager of that plant. They manage plant null. They don't manage a plant anymore, right? So we're going to set the value of the plant they manage to null. Okay, so we have both the restrict rule and the set null rule in place, but the restrict is saying we can't delete an employee as long as they're managing a plant. And then we're saying if we delete a plant, we're going to set the value of the plant that an employee manages to null. Okay, so this is kind of going in both directions for these two rules. Deletion rule number 7, or the seventh business rule concerning deletion, says if an employee leaves the company, all dependents and BCU...
Could I ask a question
Yes.
on that last one?
Yeah, sure.
When you're trying to read that later on, how would you distinguish what the meaning is since both of those letters are on the same leg of that? Would you make a note underneath to clarify what you mean by both restrict and null?
So it certainly wouldn't hurt to have a note going along with this, but because the restrict rule goes with the parent, right? So by virtue of that, we know we're restricting the deletion of the employee, not of the plant. And since set null, set default, and cascade go with the child, we know that what we're saying here is when we delete the plant, then we are going to set the employee to null, right?
Okay,
If we wanted to say that we can't delete a plant as long as they have an employee managing them, then that restrict would be here, notating that we're restricting the deletion of the plant, not of the employee. Good question. All right, number 7 says if an employee leaves the company, all dependents and BCU accounts of the employee must be removed. I think we've already captured the removal of the BCU account, but we also need to remove any dependents of that employee. Okay, so that is just cascading that deletion down. And of course, the dependent is both figuratively and literally the child of the employee in this relationship. And the cascade rule goes with the child. So we put this C right here next to dependent. Rule number 8 is also talking, or business rule number 8 is also talking about our dependents. And it says, as long as a dependent has a BCU account, deletion of the dependent is prohibited. Okay, this is interesting. So in this relationship between dependents and BCU accounts, of course, dependent is going to be the parent because dependent has the cardinality of many in this one-to-many relationship. But also, if we just think about it, a dependent can have many BCU accounts. They can have their individual account and a joint account, whereas a BCU account is going to be held by a maximum of one dependence. Okay, so dependent is the parent, and we're saying that we are going to prohibit the deletion of a dependent as long as they have a BCU account. So that is our restrict rule, and we're going to put that here with our dependent. Number 9, as long as an employee is assigned to a project, his or her record cannot be removed from the database. Okay, so we're talking about this relationship between employees and projects. And in this case, we have a many-to-many relationship. And as we discussed last week in class, in a many-to-many relationship, we can kind of consider either side to be the parent, right? Because really, a many-to-many relationship is two one-to-many relationships combined together. And we're going to explore that idea a little bit more in class next week, right? But we could say one employee is assigned to many projects and consider the employee the parent. But we also say, well, one project has many employees assigned to it. So from that perspective, project is the parent, right? But in this case, we're talking about the employee, as long as they're assigned to a project, we're going to restrict their deletion. So at this point in time, we're kind of considering the employee to be the parent in this relationship. So we're going to put the restrict up here with the employee. But then looking at the other side of this relationship is what business rule number 10 is talking about. If a project is deleted, all assignments of employees to that project must be deleted. Okay, now this is a little bit tricky because we're not saying when we delete a project that we want to delete all employees that were part of that project, because employees might be doing other projects as well, right? So when we shut down a project, we're not firing every employee that was part of that project. All we're doing is removing that employee's association with that project, okay? So when we delete a project, we want to cascade that deletion, but we only cascade it down to the relationship, to the assignment of the employee to the project. It's kind of weird to think about just cascading the deletion to the relationship instead of all the way to the entity, but we're going to see next week how this is possible. So just trust me for now that this kind of weird thing is going to work itself out. So when we delete,
just to jump in real quick,
Sure.
the cascading constraint on on dependent between held by dependent, independent of.
Right
So
here.
the dependent entity, how far down does that cascading constraint go? Like, it'll just stop at dependent?
So if dependent has any children, which in this case, BCU account would be a child of dependent, or could potentially be a child of dependent. If there was another cascade rule in place here, then deleting an employee is going to cascade down and delete the dependent, and then that would cascade down and delete any BCU accounts that that dependent has. Now, in this case, and we're going to get into this in just a moment, we have a little bit of a problem here that we're going to be restricting the deletion of any dependents that have a BCU account. So we're actually going to have to revisit this in just a couple of minutes. But yeah, the cascade will continue to cascade down, really with no limit.
So it will also delete that dependent's hobbies because it's still connected on the dependent entity.
Yeah,
to
that's a good observation. So by default, the restrict rule is what's going to be applied. But if we had the cascade rule saying when we delete a dependent, we also want to delete any record of that dependent having participated in hobbies, which is the next thing we're discussing, then yeah, deleting an employee would delete all of that employee's dependents, which would also delete all records of them having participated in hobbies.
Thank you.
Yeah, absolutely. So, yeah, what we just talked about in number 11 is this idea that if a dependent is deleted, all records of the participation of that dependent in hobbies must be deleted, okay? And again, we're cascading this deletion only to the relationship, right? Because there might be other dependents who are participating in that hobby. So just because we delete one person who's playing softball, we don't delete softball, right? We just delete all the records of that person participating in softball. So that's what happens when we cascade the deletion to the relationship rather than to an entity. And then the final business rule concerning deletion, number 12, says a hobby with at least one dependent participating in it cannot be deleted, which this is getting back to kind of a more simple scenario, which is just restricting the deletion of a hobby as long as someone is participating in that hobby. Cool. So we have captured our 12 business rules concerning deletion as they are stated in the business case. And one thing I will point out, if you're following along with the textbook, on page 98, it shows the cascade rule instead of the set null rule, which doesn't match the business rules as described in the written out case. So just kind of be aware of that. We've already mentioned that we have some kind of weird things happening that are going to make a lot more sense after next week's lecture. But as we've already kind of started to discuss a little bit, we have three situations here where our participation constraints are in conflict with our deletion rules that we have put in place, right? And this is around this relationship of employees working in plants undertaking projects, and this kind of cascading, when we delete an employee, we're going to delete a dependent, which is going to be restricted as long as they have a BCU account. So let's pick these apart and look at what is happening, and then think about how we can resolve these conflicting constraints. So we very early in creating this diagram said that a plant must have a minimum of 100 employees, right? Or at least a minimum, it has to participate in this relationship. However, we also said that as long as a plant has employees working in it, it cannot be closed down, right? We restrict the deletion of a plant that has employees. So at this point, we would never be able to close down a plant. We could never delete an instance of a plant because a plant has to have employees. But then we're restricting the deletion as long as the plant has employees. So our participation, our mandatory participation, is in conflict with the restrict deletion rule. Okay? So we might resolve this by, instead of saying we're going to restrict the deletion of a plant, we're going to cascade the deletion of a plant down to all the employees that are assigned to the plant, right? So from a business perspective, what this functionally means is when we shut down a plant, we're firing all the employees that work in that plant. Okay? Is this the right thing to do? I don't know, right? This is what we have to have a discussion with our business people about. Because instead of cascading the deletion, we could also have resolved this by using the set null rule, right? Which functionally would mean, what if an employee had a null value for plant? What would that really mean?
They're unassigned?
Yeah, they're unassigned, right? They're doing what a lot of us are doing right now. They're like working from home, right? They're not assigned to a plant that they have to go report to every day, which might be a very reasonable solution for a lot of businesses. However, if all of these employees are like people that have to be at the plant to pull a lever or push a button or move something from one line to another, it probably doesn't make sense for these employees to be working from home, right? So maybe cascade is more reasonable than set null in this business case. Or we could also resolve this by using the set default rule, right? Which would just, when a plant closes down, reassign all those employees to some other plant. And that might make sense if we have like a dozen different plants in one city, right? But if you've got one plant in Houston and one plant in Phoenix, Arizona, and one plant in Omaha, Nebraska, you don't want to shut down a plant and reassign all your employees in Houston to go report to Omaha the next day, right? That doesn't make sense in this business case. So, set default technically would work, but might not be a good solution for this particular business case. Of course, we could also resolve this by making the participation in this relationship optional for plant. And at that point, we would just need to either reassign or fire all the employees that work in that plant until we didn't have any employees assigned to that plant anymore, in which case the restrict rule would be fine. Okay, but yeah.
Professor?
Yes.
If the participation was changed to optional, would you also be able to cascade that into the relationship that works in? Or would that throw off everything for all the other plants?
If this was optional, if this participation was optional,
Yes, sir.
okay,
Could you do the cascade rule applying to the relationship, similar to how we did hobbies, dependents and hobbies, or would that not work?
Oh, okay. Good question. Good question. So we can really only apply our deletion rules to the relationships when we have many-to-many relationships. And why that's the case is going to be a lot more clear when we have our discussion next week. But yeah, you really can't cascade just to this relationship. It would have to go all the way to the employee. Yeah, good question. So anyway, the book recommends that for this particular business case, cascading is what the company wants to do. But just keep in mind, and as we discussed last week, there are multiple ways that we can resolve these deletion conflicts, and it's all going to have different business implications depending on what we pick, right? So we fixed this first one. In this next one, we say that if we close down a plant, we're going to just set the project temporarily to have a value of null for the plant that is managing that. But that is in conflict with this idea that a project must be assigned to a plant, right? We can't have a project not be assigned to a plant because we say project has total participation or mandatory participation in this relationship, okay? So the book suggests that we would resolve this by loosening that constraint and saying, well, you know what, maybe we will have some situations where a project is not associated with a plant, right? So that we could temporarily have it unassociated so we can figure out what we want to do with it. Now, of course, there are other ways we could resolve this. Instead of loosening the participation constraint, we could cascade the deletion of a plant down to a project, right? In which case, when we shut down a plant, we would say, you know what, we're shutting down all the projects that go with that plant. It's a pretty reasonable approach. We might also do a set default, right? So when we close down a plant, then all that plant's projects would automatically be reassigned to some other plant. Okay, that might make sense if all of your plants are doing the same types of projects. But then again, it might not make sense if you have some plants that are equipped to, create widgets out of iron, and other plants that are equipped to, carve things out of wood, and other plants that are equipped to paint things, right? Maybe that wouldn't make sense, right? So there's just different business implications to the way we resolve this, okay? But in this case, it's suggested that just loosening up this idea of a project having to be assigned to a plant all the time, that's one way that we could resolve this. And then it would be possible to have a project that has a value of null for the plant that it's assigned to. And then the third issue here is this idea of when we delete an employee, we're going to cascade that deletion down to the dependent. But then we have this issue here where if a dependent has a BCU account, then we're going to restrict the deletion of that dependent. Okay, so what's going to happen here is if we try to delete an employee that has a dependent and that dependent has a BCU account, not only are we not going to be able to delete that dependent, we're also not going to be able to delete the employee, because the employee or the dependent can't exist without having an employee that they are a dependent of. Okay, so since we've already said when we delete an employee, we're going to cascade that deletion down to their BCU account, it probably makes sense to say when we delete a dependent, we're also going to cascade that deletion down to the BCU account. Okay, so there's a number of other things we could do, of course, that might not make much sense. Like we could have a default person that we're just going to reassign all of these orphaned BCU accounts to. Like, it would be great if I was that employee that gets reassigned all the BCU accounts that deleted employees and deleted dependents are leaving behind. But yeah, I think this idea of cascading the deletion down to their account maybe is more reasonable, but different business implications to the different ways we might resolve these conflicts. So at this point, I think our ERD is in pretty good shape as far as not having any conflicting deletion constraints and structural constraints around the participation of our entities. But yeah, as we discussed, just keep in mind that there are almost always going to be a couple of different alternate solutions to resolving these conflicts, and they have different business implications. So what we have here, just kind of for your notes, is what we've already talked about and kind of the deletion business rules that are described in the story. And do keep in mind that there are other business rules that might not be able to be captured in the ERD. So we're going to capture these in the semantic integrity constraints, or just kind of a bullet point list of constraints that are going to go along with this drawing of our entity relationship diagram. And these might capture things about our attributes, about the entities, about deletion, just kind of miscellaneous things like that a husband and a wife can't both work at Bearcat Incorporated, because I don't know how we would really capture that in our diagram. So that just has to be a document that goes along with our diagram. Also, things like our domain constraints, can't really capture that in our diagram, but in the story it describes that all our plant numbers have to be between 1 and 10. Gender is either male or female. Project numbers range from 1 to 40. These are the only project locations, things like that. And then just a few more kind of things for your notes, distilling the business requirements out of the longer document. So at this point, as we've added more and more to our ERD, we've moved from what we consider this presentation layer ERD, which just captures our entities and the relationships, into a design-specific ERD, right? Which captures details about our attributes and their data types and our cardinality and our participation constraints. And it's getting maybe less user-friendly and less easy to describe to our business people, but it's getting more detailed and more specificity built in, right? And so what is the correct level of detail to be showing to your business people, right? This is something that you kind of have to decide and figure out what their willingness to be involved in different levels of technical specificity is, right? So is it the presentation layer? Is it the design specific? Is it what we're going to be talking about next week, the decomposed design specific, where we start moving into a world where not all of our entities and relationships are going to be directly related to the business case as it's been presented to us, but where we start introducing some artifacts that have to be present in order to transform this into our data definition language code. We start introducing some entities that are not directly the result of the business problem, but are the result of how we technically are going to have to implement this in the database. And that's when we get into our decomposed design specific ERD. So we're getting more and more precise as we get deeper into this, right? And so here we're starting to add some notation here to describe whether these attributes are alphanumeric or date time attributes, right? Generally, it's using the look near notation is going to be a little bit more precise, since we can capture things like our minimum participation. So this is our design specific ERD, and then we're going to take this just one level deeper in class next week. So next week we are going to be looking at how we model multi-value attributes, because this is something that although we do represent them in our diagram, like building and also our composite attributes, these are not things that we can technically implement in our database. So we're going to look at how we actually technically model those and how we actually capture those, and then also our many-to-many relationships, and introduce a new type of entity called the gerund. And when we start getting into this discussion, we're going to get a better understanding of what it meant to be cascading deletions down to the relationship instead of to our entities. So we're going to be looking at modeling multi-value attributes and our many-to-many relationships. We're going to talk about data modeling errors, and then kind of be transitioning into a more technical relational data model, and talk a bit about set theory, and just kind of take a holistic look at what we've been doing so far this semester.